All right. My name is Mathias, and if you've seen the current schedule on the website for PSConf, it's a little bit misleading. You may not recognize me from the picture that's currently figuring there. Um, I'll get to that in a second. But who am I? My name is Mathias. See, I didn't even add that here. I usually go online by IIS-reset-me. You can find me on GitHub, find me on Twitter using that handle. I work as a security administrator. That's a fancy title for a sysadmin that does security engineering in something called the Corporate and Cloud Security Team at Booking.com. Prior to my stint in the online travel industry, I used to be an IT ops and normal sysadmin, and this is kind of where I got into this whole PowerShell mess. Privately, I'm obsessed with this product, with PowerShell. I spend most of my waking hours outside of work, seeking out interesting problems. I spend a lot of my time on server fault, on Stack Overflow, trying to find and answer interesting questions that people come up with in their course of using PowerShell to solve problems. So early this year, back in July, I saw that they were announcing speakers for PSConf Asia, and PSConf Asia was the first major PowerShell conference that I ever spoke at 2 years ago. And so I felt a bit bad that I hadn't actually submitted anything this year, but I thought this is going to be interesting. I'm just going to go as a regular attendee, see some interesting talks, talk to some people. It's going to be nice. Then on Tuesday, back in Amsterdam, as I was packing and I was on my way to the airport, I got a message from Jaap. He said, hey, you want to speak at PSConf Asia? We had a last-minute cancellation. And I was like, I mean, I'm not known for like planning things well in advance, but you know, Tuesday the same week, really? Okay. So I was sitting at home. I was actually sitting at the airport. I was thinking, okay, now I've committed to this. What are we going to talk about? Okay, I got to measure, I got to gauge what people want to hear about at this kind of thing. So I put up this poll on Twitter, and I thought, okay, PowerShell performance. Everybody always wants to know how can we get our scripts to run faster, our tasks to complete faster, use less resources. One of the things I've been talking about in the context of PowerShell in the last couple of years is also regular expressions. This seems like black magic to the uninitiated. It's not necessarily black magic, but it is a bit convoluted, and it's something that's super interesting for at least string processing, which is something people run into all the time. I'm also a huge proponent of helping others online. I think at this point I've submitted 1,700 answers on Stack Overflow and the PowerShell tag alone. And helping others helps yourself, right? When you teach, when one person teach, two people learn, right? And so I found that helping and teaching others, both online and in real life, has really helped my own understanding of the problems I've been looking at. And then finally, kind of my first kind of deep technical dive into PowerShell programming languages, coming from kind of a non-academic background, has always been type systems, and especially the .NET type system, which is kind of famously reflective, like it introspect on its own types, and we're going to get a little bit into that. So people voted. PowerShell performance and type systems and reflection kind of came out on the top. Regex is also kind of almost a dead heat. So the agenda for today is we're going to do a crash course in data types. We're going to do a crash course in PowerShell performance optimization. We're going to do a crash course in Regex mastery. And then I'm going to take questions, and we're going to do all of this in the next 38 minutes. Yeah, so I should stop talking now. All right. So basically, all of this comes down to how do I take my PowerShell food to the next level, right? Have some understanding of the language, done some things, done some cool DevOpsy automation things, but how do I kind of take it to the next level, right? So for the first thing, data types, you could read a book. They've been around for ages. This is a great book by Niklas Wirth, the guy who invented Pascal. I think it came out in the 70s. Great read. If you want to learn about performance, or have better performance, just upgrade PowerShell. Everybody knows that with each version, it gets faster and faster and faster. And with PowerShell core, with a bunch of community contributions, we see stuff like this, right? Someone using group objects and 20,000 objects, and all of a sudden it goes from like, what is that, a 60, 70 time performance improvement in time complexity, right? This is pretty amazing. So just upgrade PowerShell and you'll be good. Finally, for regex, just tweet at Jakob. He's getting into this whole regex thing, so he'll answer all of your questions, and you'll be a regex wizard in no time, right? And with that, I want to say thank you for coming to my talk. See, so we covered all of these topics in less than 3 minutes, right? And you're all ready to go on being PowerShell wizards, right? Okay, so if any of you felt that I maybe oversold this a little bit, we're going to reveal the actual agenda for today. We are going to have a crash course in type systems. We're going to do like a quick reflection demo at the end. And then if we have any time left, we're just going to open up PowerShell and do like a free-form performance demo. If you have any questions, any things you're curious about, or any things you want to know, how do I figure out how to make something faster or why it's slow, we'll take that at the end. Before we jump into the whole type system thing, I want to kind of make one thing clear. Anyone who works with computers should understand this conceptually, at least. This is not just true for optimizing for speed, but this is true for anything we do that have to do with the computers we work with, right? You need to understand that everything is made up of a bunch of complex abstraction layers, right? And this ability to abstract problems away to a lower level in software or in hardware or mechanically means that we can have high-level programming languages like PowerShell, right? It's almost like English, right? It's kind of readable if you write nice code at least, without needing to know how a CPU register works, right? You can take advantage of the CPU without knowing what the instruction set for an Intel CPU is. And the reason for this is these multiple layers of abstraction on top of each other, right? Usually when we're talking about optimizing our scripts for faster execution, what we need to keep in mind is that the more layers of abstraction we have on top of each other, the more complexity there is, right? The more layers of translation the computer kind of needs to do before you kind of reach the CPU. So as a general rule of thumb, anything that's going on inside the CPU is going to be lightning fast, right? Your CPU can do billions and trillions of operations a second, whereas you probably can't call a trillion PowerShell functions a second, right? The layer above that, anything written in assembly, the hardware abstraction layer in Windows, it's also going to be fairly fast because it's, again, very close to the hardware. And so as we kind of build our way up, things get more and more complex, and things get a little slower. There's going to be a little more overhead for kind of translating from one layer down to the next, and so on and so on. There's also some physical limitations to this, right? Like anything in the CPU register, right? The memory registers that are physically on the CPU die are physically very close to the processing unit itself. And so copying information, copying bytes, right, is really about moving electrons from one place to another. And so the physical distance between the memory register and the CPU cache is very short compared to, let's say, the RAM in your computer or even the hard disk, right? And I think a lot of people neglect the fact that we're talking orders of magnitude here, right? If the distance between the CPU cache and the CPU is like me walking over to the coffee machine out here, if I had to walk all the way to the main memory, the RAM in my system, I would have to walk all the way to Malaysia. Like this is the order of magnitude we're talking about, right? And it's not really comprehensible. It's not the way we're used to thinking, right? The way we think in distances and sizes are influenced by kind of our lived experience, right? Like I can see you right here, Raymond. I can almost touch you with my arm, right? So these distances are kind of what. But I think this is worth keeping in mind, right? Specifically for PowerShell, anything you write in the PowerShell language itself, right? So script functions, function, command set binding, whatever, is kind of at the highest level, right? The highest abstraction level. It's super easy. Anyone can open the editor and do it, but know that there's a bunch of many layers of abstraction underneath, right? This is also usually why built-in operators, statement constructs in the language are usually a little faster than like using the pipeline or using functions. And again, compiling a commandlet from something like C# or VB.NET is going to be even faster, right? Because you get kind of fewer layers of abstraction in between. All right, with all of this in mind, let's talk about the type system that PowerShell's type system built on. So what we're going to go through here is I'm going to try to answer the question, very high level, what is a type system? I'm going to talk a little bit about the type system in PowerShell, often referred to as the extended type system. We're going to talk about the underlying type system that PowerShell extends in the first place, the common type system, which is kind of core to .NET. What kind of types we have in that type system, what the logical structure of them is, and where this kind of commonality comes in, and why this is interesting. So before I maybe gave the impression that I can make you master of anything, I have to be honest here, I have no idea what I'm doing, right? Just hacking away, and kind of want to have you take away the message that spend some time on this, dig into these concepts, learn how to use Google, for God's sake, and you can become a master of anything, even though you have no idea what you're doing. All right. So, what is a type system? In the context of computer programming, a type system is simply a set of rules, right? A set of rules governing data types, right, in a programming language or in a computer program. So what is a data type, right? A data type, at least in kind of object-oriented languages, is a core property of an object. A data type can be described as kind of a contract for the behavior of an object at runtime. It's typically also a contract for operator behavior, at least in .NET or C# or PowerShell, for example. So when you take a number and use the plus sign and then another number, the behavior of that plus, that addition operation, is going to be governed by the type of operands, right? So if you say the number 1 plus the number 1, you're going to sum these two numbers, whereas if you give it a string plus a string, then we're not doing summation anymore, we're doing concatenation of strings, right? So the data types of these operands that we provide actually kind of define the behavior of the operator itself, right? The plus operator is not just summation, right? It could also be concatenation or anything else. The idea of a type system or the idea of a data type is not specific to object-oriented programming, right? In fact, if you start looking into something like functional programming, data types are really integral to what you're going to be doing. So back to the first question, what is a type system? A type system is simply a set of rules that govern types. Now, why would you spend time designing an elaborate type system for a programming language or for your compiler? Well, the aim is to reduce runtime errors, right? The idea is that the interpreter or the compiler of your code can apply these rules to how the objects interoperate, and then hopefully your computer won't crash or start burning when you actually run your computer program, right? So that's a pretty good aim, right? The side effects of having strict type systems in place are that the compiler or the interpreter can also do a bunch of memory optimizations that's built in. And in the case of languages like Java or C#, we also get reflection, which we'll get into after this. Usually a type system that comes with a language or a framework or runtime includes like a core set of types that are kind of natively recognized. And a type system may include extensible types, and we're going to look at what that looks like. So before we talk about PowerShell, anyone here familiar with any other programming languages than PowerShell? Yeah. So JavaScript, for example, very common on the internet, right? Perl, PowerShell borrows heavily syntactically from Perl, another kind of scripting language that used to be referred to as the glue of the internet. And then finally, Java and C#. These all have different type systems with different characteristics. In JavaScript, for example, functions are king. Like JavaScript is a fairly functional programming language, and so the basic types that are recognized in JavaScript would be a string, a number, booleans or true or false. You have an array type or an array prototype. You have an object, it's a kind of a dictionary-like object, and then finally you have a function, which in itself is also an object in JavaScript land, right? The last type, the object, this dictionary-like type, can be extended to define anything in JavaScript, so you can kind of extend that to define whatever you want, right? In Perl, it's a little more simple. You have something called a scala. A scala can be either a number or a string. Perl will try to figure out what you want, like at runtime. It can be a little confusing if you're coming from a strongly typed language. Perl also has an array construct, and then it has something called a hash. And I think we're going to show some examples of what a hash or a hash map is when we get to the performance In Java and C#, it's a little bit different. Both of these languages or both of these frameworks have a hierarchical type system, where at the very top you have this generic type called an object, right? That's very vague, it doesn't say anything. But you have this object with a few defined methods or behaviors, and then everything else extends from that. Everything else is an extension of object, right? So you take object and then you add some functionality to it, and boom, now you have a new base type. So what does this have to do with PowerShell? Right? So much of PowerShell's extensibility and its kind of usefulness comes from what we usually refer to as the extended type system. And so this is also sometimes called the adaptive type system because it's implemented using something called a type adapter or a set of type adapters. And so what this looks like is, I've tried to kind of visualize it here, but the idea is that any object in PowerShell in your shell, right, is a .NET object that's wrapped in this kind of transparent layer called a PS object. And the PS object has a couple of interesting properties. It has a reference to the original .NET object that is kind of wrapping around. And then it has a couple of member sets. It has an extended view, .ps extended, that you can access. I'll show this in a second, where you can kind of add extended properties to any object, right? It also has something called an adapted view. This is interesting for not .NET types, but WMI objects, XML objects, so types that are kind of adapted in a way so they kind of get this native PowerShell syntax, right? You can open an XML document and you can kind of use dot notation to kind of enumerate everything that's in an XML document. The PS object also has a couple of other things. Not everything is shown here. It has a property called PS type names, with which you can kind of override the type name of an object. This is very useful if you're doing stuff like custom formatting or adding type dates at runtime. And so let me just show very quickly what that looks like. Switch my screen here. Everyone see that? You need to make it bigger. Right. So kind of the most simple example is we have these automatic variables in PowerShell. One of them being profile, right? Is everyone familiar with the profile automatic variable, right? So the $profile variable refers to your profile script, right? So every time you open up a PowerShell host application, it has a set of profiles that it tries to load, and so here you can put like user-specific settings or host application-specific settings, right? Like you want the prompt to look different, or you want to update the color scheme, you want to define some functions or set some aliases, right? So $profile, okay, what type is this? Every single .NET object exposes this function called getType, with which we can inspect the type, right? And so if we look at this, so getType, you see, okay, this is of type string. If we get full name of that, okay, system.string, right? So if we open our browser and we go to Google and we search for system.string.net.microsoft.com, there's going to be some nice documentation on the Microsoft website for what a string looks like, how a string behaves, right? Here, yeah, a string represents text as a sequence of UTF-16 code units. We all know what a string is. And down here, I have to apologize for my laptop. It sounds like a jet engine is taking off, but yeah, it probably is. So down here we can see that the string class has a bunch of properties. It has some methods that you can call here. And so this is also always going to be true for any kind of string. You can call these methods and interact with it this way, right? So there are some examples in here. Now, in PowerShell, again, like we've just determined that the $profile variable is of type system.string, right? So we should expect it to have the exact same methods that as we just saw on that docs page, right? And so one of the methods down here is split, for example. So we can split by a set of characters. So we do something like this, and so it splits the string by by the character I put in there, right? So it seems to behave like a string. But profile also has something else. So all users, all host property. This didn't show up when I looked into the documentation. It says here that it only has a parameterized property called chars. It has a property called length. But there's no mention of this all users, all hosts. So what is this about, right? It also has current user, all host, current user, current host. So where does this come from? So this is this extended type system that we were talking about. Some properties are being added to this string object that otherwise would not have been part of the string. We can inspect this using the getMember commandlet. So we say getMember. We're only interested in properties. So it is indeed going to show us here all users, all host, all users, current host, and so on and so on. This is not a normal property. These are node properties. So these are kind of nodes that are being stuck onto this object, but we can interact with them just as if they were native to this data type, right? As I said before, if we look at the slide, there's this extended view where things like node properties are attached. There's an adapted view for adapted types, so XML, WMI, so on. And we can actually we can kind of access these underlying member sets. They're hidden by default. So if we say getMember, member type, member set dash false, it's actually going to show us that it has these weird member sets that are also not part of the native .NET object, right? So this is PowerShell specific. So on any PowerShell object, you can do .ps object, and you can actually see what properties are attached, like all the properties, not just the .NET stuff and the stuff that isn't hidden, right? All right. So this thing right here is basically the original .NET object that we wrapped. I want to dig a little deeper into that. So what is it that we are extending? So PowerShell's extended type system, as I said, is extending .NET's common type system. And .NET's common type system is kind of what gives us language interoperability in .NET. It means that you can write a piece of code in C#, in FSharp, in Visual Basic.NET. There used to be a language called J#, which was kind of a JavaScript clone before C# took off. This is very old graphic. But the idea is that a language team at Microsoft or anywhere else can define a new programming language. They can write a compiler for it, and as long as the compiler targets a set of rules that is commonly referred to as the common language infrastructure, then it can run in the .NET CLR, the .NET runtime, right? And that means that all of this code that's written in different languages, compiled on different compilers, can now interoperate at runtime, right? So I can write a piece of code in C#, Chris can write a piece of code in C#, Alex can write something in VB.NET, and we can have it all come together in one big project, and it'll work together harmoniously and wonderfully, right? So I think this is kind of the real magic of .NET, right? The Java JVM has something similar, and over the last 5-6 years, we've seen like a proliferation of many different languages that run on the JVM and can interact with Java, right? This is speculation on my part, but I think like that push on the Java JVM probably came from this, right? Like C# became super popular, VB.NET kind of gained adoption, and they kind of saw, oh, this is actually pretty powerful, right? Right. So the .NET common type system, what kinds of types do we have? So the type system in .NET basically has two kinds of types. We have value types that we can kind of put into two categories. We have primitive types, so that would be something like an integer or a byte, Boolean. So these kind of small numerical data types that can kind of fit in to a fixed size of bytes in memory. We have one more kind of value type, which is a composite type. So this would be a struct, right? So we can define a type that consists of multiple primitive types, for example. So an example of this in .NET would be the datetime struct. When you do getDate, you get an object return of type datetime, and datetime is really just made up of a bunch of other simpler numbers that represent a place in time. Then we have reference types. Reference types are classes. So if you want to implement some complex business logic, right, with a reference to other data types, both simple and other reference types, you sit down in a language like C# or from PowerShell 5.0 on, you can also sit down in PowerShell and write your class. And then a class kind of works as a blueprint for a new copy of an object, right? So if you want to create a new copy of an object, use a class as a blueprint. There's a special class as well, the enum, which was also introduced in PowerShell 5.0, which is basically a data type that just has a static list of values that you can refer to by name, right? Enum is a special type of class, and I'll show you afterwards when we do the reflection demo. So the values that are exposed, right? So you do the enum type and then colon and then the enum name. Then the underlying value of that would be a value type, right? That would be an integer or a byte or something like that. But the enum itself, the enum type, is actually a special kind of static class, and I'll show that afterwards.
Important here is a value type, so on the stack, and reference type.
So I'm not sure there's actually a guarantee of this. I don't know if you know this. Oh, right. Okay.
Implication of normal language.
Absolutely. There's one more thing. Oh yeah. The other defining difference on this is that when you pass a value, a copy of a value type to a method, for example, when it's a value type like an integer or a byte or a struct, it will get copied into that method. Whereas if you pass a class like a complex object, right, what gets copied into the function is a reference back to that same object. So if you pass a number into a function and you manipulate it inside the function, the original number is going to stay completely unchanged because you're manipulating a copy of it. Whereas if you pass an object, you're really passing a reference to an object, so the function will be writing back to that same object. Big difference, yeah. I think this kind of maybe bites people who are not familiar with this. Right? So very quickly, the logical structure of how the code, the resulting code is structured is that we can organize everything into namespaces. We can nest namespaces into other namespaces. Namespaces can contain classes. Classes themselves can contain nested classes or nested enums and structs. On the top here, we kind of have the logical layout of what a piece of .NET code after it's being compiled looks like. And then on the bottom, it says physical. An assembly is basically a DLL file or an exe file, right? So you take some code, you compile it, and then you get like a DLL file with all of these data types inside. A class definition or an entire namespace can span multiple assemblies. I think this is a little bit different from Java, if anyone is familiar with that. So you might find that in order to use a certain class from a namespace, you may have to like import two different DLLs, for example. This is the case for some of the things in the Windows presentation framework. All right, so said this was called the common type system. Where's the commonality of all of this? So I think the best way of showing like the power of this is to just write some code. This may be a little small. Everyone read this? Yeah, let's go. Okay, so I am not going to start here. I am going to start over here. Right. So is anyone other than Jakob familiar with FSharp? No? Okay. So FSharp is a functional programming language that also compiles against .NET. And you don't need to be familiar with the syntax. Like if this looks weird, that's totally fine. But just know that this is how you define a new type, or this is one way to define a new type in FSharp. So we say type, the type name, and then we have some constructor arguments here, and then FSharp has kind of optional typing. Otherwise, it'll try to infer the type of argument you pass to it. So I'm going to create this type here with a constructor that takes a string and something that needs to be coerced into an integer, and then it has these three properties here: name, age, and comment. So what I'm going to do now is I'm going to build this solution. The FSharp compiler is going to take this code, turn it into a DLL, right? That succeeded, very nice. I'm going to copy the output path here. And now here I have another completely unrelated project. And in the references over here, I am going to add the path to the code that we just compiled, right? So this is the FSharp code that we just compiled into DLL. I'm going to add this as a reference into my C# project. Yes. I'm going to add a reference to the my FSharp class namespace. And now we can start consuming this FSharp person data type that we just defined in a completely different language, right? This is pretty cool, right? So now we have some interoperability. So like, I have a colleague who doesn't like C#, he wants to do something more functional. It's great. Just go ahead, you do it in FSharp, and just give me the library, and I'll take care of the rest. So here we're going to create yet another data type, this time in C#. This could be for an access control system. So we have something like a role mapping. So we need the definition of a person and then the name of the role. And so I'm also going to compile this, build this solution. And then we're going to go into PowerShell. Is everyone familiar with this commandlet add type? Right. So add type allows you to both call out to the C# compiler. You can actually paste in a string of C# code and have it compile. But you can also add references to libraries on disk or assemblies and like get that imported into your PowerShell process. So I'm just going to do the path to the DLL that we just compiled here. I think that's fine. And if we go back, you see the namespace was a C# class and then role mapping. So now, let's see that as role mapping. And so now, you see, we have a constructor that actually takes this FSharp person object from the original FSharp class. And so we're going to create role mapping, and we're going to give it a role administrator, and then over here we're going to create an instance of this FSharp person object, which took a name. Fred, you're now the admin. Let's say you're a Highlander and you're 1600 years old.
No surprise then.
And now we have this role mapping object of type role mapping that has a property person, which is of type FSharp person. And as you can see here, it has all of these properties that we define in FSharp, right? So maybe this is just me getting very overexcited about this, but I think this is pretty cool, right? We just wrote something in one language, imported it into a project that was written in another language, and now we're interacting with all of this in PowerShell. It's pretty cool, right? Absolutely. But this is kind of the flexibility that affords you, right? You have one tool that you prefer, I have another tool that I prefer, and we can still work together and don't have to get into flame wars about who has the better tools as long as we're solving the job, right?
Can still get those flame wars going.
Sure, but that's a different story. Right. So basically, what this all boils down to is that the common type system, as you just saw, it's kind of language agnostic, right? It's the exact same type system that works with different languages. So basically, what makes up the type system in any .NET language or any .NET compiler is a set of language-specific type constraints that map onto the common type system. So in C#, for example, you have a bunch of native types like the int, the bool. They map onto some built-in types in .NET type system. So that would be system.int32 or system.boolean. And they kind of map onto these value types and these reference types that we have in the common type system itself. The common type system since version 3.5 also has something called generics, which basically allows us to define data structures that reference data, the type of which we do not know when we define it. And I'll show an example of what that is about. Right, time to shell out. As I said, we're going to do like a quick reflection demo, kind of this core property of the .NET type system, and then we'll take some questions and try to do some cool fun stuff with some of the things we just learned. Right. So, this whole reflection thing, as I said, this ability for an object or for a piece of code to kind of look back at who am I, what type of data am I, right? Like the get type thing, a string, for example, this is already kind of the most basic example of reflection, right? The string can tell us what type of data it is. So, did anyone here go to the workshop we did on Thursday? Yeah. So I think at some point Jaap showed an example of how you can use reflection to figure out what data types are available in your process or in your app domain. And I think he kind of glossed over it because it was not really what we were talking about. But let's see if we can find that out, right? So we all know that we have these built-in data types, right? Like integers and strings, and most of them have type accelerators in PowerShell. So we know some data types and some data structures already. But if we want to figure out all the data types, all the classes, all the enums, and all the structs that are available in our .NET application right now in PowerShell.exe, there's this class called app domain. App domain represents kind of the outer boundary of any .NET runtime. So app domain, current domain. The app domain exposes a function called getAssemblies. As I said before, an assembly is roughly a DLL file, right? It's a code that we import from an external library. And so if we look at this, I haven't imported any special modules. The only thing I did was the app type with the two types that we just imported, right? So if we look at how many assemblies are in PowerShell by default, measure object. Okay, so we already have 41 libraries that are imported by default, right? 39 plus the two ones we just compiled. Okay. Now, each assembly exposes another method called getTypes that will show us every single type, so every single class or struct or enum or whatever is defined within that. So we can do something like getAssemblies, getTypes, and now I have 30,000 data types already available to me, right? So a lot of people have been asking, like, do I need to get into this whole PowerShell classes thing? Do I need to define my own data structures? 9 out of 10 times, I'll say that there's probably already a generic data type out there that you can use for whatever purpose you're trying to solve for, right? All of these types. The type system in .NET, every type has a property called isPublic, which basically means, can you instantiate this? Like, can you do a new object and then the type name? Like, is it exposed for you to use? And so if we filter in this, so we say, true. We still have almost 10,000 data types which we can consume and instantiate and work with, right? This is true. So it's not just classes and enums. .NET also has this concept of interfaces and abstract classes which have methods and properties defined, but they don't actually implement any code. And so you can't create copies of them. So they're being used as type constraints for other classes that then implement them. If you say something like this abstract is false. Okay, so we're down to 8,000. Again, there should probably be some data types in there already that you can reuse. Some of the most useful ones I find for like when you're doing large-scale data processing, for example, and you're running into time constraints, all of a sudden you're You know, you used to process 5 XML files a day using some scheduled task, and it used to run in a couple of minutes, and it was all fine. But you know, business grows, and now you need to process 6,000 XML files a day, and all of a sudden the script is really slow, right? I think it's worth noting that there's a whole academic discipline out there dedicated to analyzing the time complexity of functions in the first place. You don't need to be a CS PhD or anything like that. You don't need to a degree in mathematics and space-time complexity. You just need to understand that exists out there. So what I usually do when I'm trying to figure out, what is the time complexity characteristics of a data type, usually search for something called big O notation. I don't know if you've ever seen this before. But this is kind of the standard way of describing the time complexity of a function. So if we go down here, it should be a very nice chart. Again, these are some common descriptions for the time complexity for functions. So down here you can see, for example, if the time complexity of a function is O1, then that means it's constant time. So if you're operating on small input, large input, 2 files, 6,000 files, it doesn't matter. You're always going to get it's always going to take the exact same time per insertion or lookup or whatever you're looking at, right? Again, if you get up here, you get into like exponential time complexity. So the more data you add to your input, like it gets exponentially slower, right? So like with 5 items, it's maybe fine, but once you get to 10 or 100, you have code that's so slow that like your computer is burning for the next day, right? Again, you don't need to remember any of this. You just need to know that this exists and that you can Google it, right? Because there's been plenty of examples of this written. Usually, also when you search online, Wikipedia, docs.microsoft, whatever else programming guides you can find out there, if you search for something like an array or a dictionary, it will have some performance characteristics as well. So it will say like, oh, the insertion time into a hash table, for example, is constant time, so it'll be O.1. And so all you need to do is just go back and Google, like, is O1 good? And you'll find out that O1 is very good because it's constant time, right? So a good example of this is kind of the classic. If we create an array, an array in .NET is fixed size. So when I create an empty array, I've created an array that has a capacity of exactly 0. PowerShell tries to be super helpful and allow me to add new objects to this array. But .NET can't handle this, so what PowerShell needs to do in the background, it needs to resize this array by creating a new array and then copying all the data from the old array over. This happens in the background transparently, right? So I could do something like array +1, and the length and capacity of the array will just update automatically, right? And so this seems to be going pretty fast. But when you do this 10,000 times, and the type system needs to resize and copy that array 10,000 times, that's going to be very slow. So if we do something like, again, we define our array, measure command to say, array, you can see it's getting pretty slow, pretty fast, right? And so now it took us almost 10 seconds to just add 10,000 items to an array because in the background PowerShell needs to resize all of this. So there's a couple of ways you can get around this. First of all, you could stop using fixed size arrays. As I said before, in .NET 3.5, so that would correspond to PowerShell 3.0, unless you're running an XP. I think 3.0 was downported to XP. We have these generic types. So we have something that said like a system collections generic list, and then all we need to specify as a parameter here is the type of thing that we want to add to that list. So here that would be an integer. We create this. These generic lists are optimized for being resized, and instead of adding one item and like copying the entire thing over, the list will resize itself to double its size once it reaches its limit. And so this is going to be way faster than what PowerShell is trying to do for us in the background with the array. So if we do something like this, add. We're going to see that we already cut the time in more than half, right? It took like 40-45% of the time that the array resizing did in the background. What we could also do, for example, is that if we know the input size up front, right, we know that we have 10,000 items. I think at this size it may not make the biggest difference, but what we can also do with these generic collection types, add a count to the constructor, and then it'll upfront size the list and say, like, I know I'm going to need 10,000 items in here. Get a little faster. Not that much. So I don't know if how much time do we have? None.
Yeah.
Okay. So I had a bunch more examples I wanted to go into, but if this is interesting, feel free to hit me up afterwards.
One thing, talking about Inline reflection model. There's a PowerShell model I've seen recently. Inline reflection.
Oh,
and then
yeah.
you can have access to all private properties and methods by just one single command that you're able to feature it. Brilliant.
Yeah.
Yeah, right. Yeah. Brilliant.
So natively in PowerShell, right, you can do something like string, you have a type, get members, and then you can specify that that you want non-public members, non-public instance members, and it's going to show you all the private properties, right? But this becomes kind of terse, right? Nobody wants to. So this is all automated way in the implied reflection module, right? Yeah.
And
very nice.
support IntelliSense. So you press the IntelliSense and then you see also the private.
Ah, very nice, very nice. So implied reflection, if this reflection stuff is interesting and you want to play around with types and kind of see what's going on behind the scenes, absolutely.
No, you do one enable implied reflection of your model.
Is there a break after this one? And
Yes.
then maybe finish it?
If there is a break,
Sure, yeah, you can go another 5 minutes.
Sure.
I thought it's like half an hour.
Oh, wait. Yeah.
Of break till 30 maybe. So
Oh, yeah. So, yeah, if you...
I don't want to keep you here forever, but there's at least one more thing I'd like to show. Everyone here knows what a hash table is, right? It's this one, right? Or hash. So, thanks. So a hash table is a kind of dictionary, right? It has like a key and a value, and you can look up the value of that key. Due to the way this type of dictionary is implemented in the background, it has some very interesting performance characteristics. Due to the way it's implemented, you can look up a key, you can find out whether a key exists in a hash table in almost no time. So a hash table is a perfect data construct for like storing a set of values for later looking them up, right? So instead of having a big array of objects and then piping them to where object and then figuring out the one you want, looking them up in a hash table is going to be way faster, right? So if we have something like an array of 200,000 numbers from 1 through 200,000, and then similarly we have a hash table. With the 200,000 same keys. Just going to create that here. Doesn't matter what the value is. This is the slowness of the pipeline, I promise you.
That's the free job.
Yeah. Ooh, I saw a very interesting suggestion the other day. Use an inline filter instead. And then, yeah. And then there you go, way faster, right? Did you see that? Instead of using for each object, when you invoke for each object, PowerShell in the background needs to do a bunch of what's called parameter binding. It needs to figure out what all the numbers, which parameters there are to be bound to, right? So it does all of this magic in the background, but that adds a whole lot of overhead. So what you can do instead, you can just pipe it to the the invocation operator, and then say process. The process block will always execute once per input item, right? And so $_ will refer to whatever we're piping in. And so this is going to be a hell of a lot faster, right? Almost instantly. If you don't like this syntax, it's like, oh, this is kind of weird. Has anyone heard of what a filter is in PowerShell, right? A filter is almost like a simple function, but the only difference is that when you write a simple function, you know, without like all the advanced command-line binding stuff, by default, the end block is going to execute when you just have a single function body. A filter is different in that it executes the process block instead of the end block. And so this is perfect for like pipelining things and like mapping functions. So we could also express this as and then instead of function, we will write filter. Otherwise, syntax is almost the same. Huh? Oh yeah, it absolutely was one the name. So just like a function, you could give you a filter a name. So filter to highest table. But so defining a filter is going to do the exact same thing as what we did here. And now just call the filter name at the hash table. That was also pretty fast, right? So the loop construct, right, for each object, or for each in, is going to be way faster than for each object because you do not have any of this pipeline binding. It only invokes the same body 200,000 times, and that's way faster. There is one difference in here, and that is before the first execution of the loop body, this value expression needs to be completely evaluated. So that means that in this example, it doesn't make a difference because the range operator is going to expand to a huge array before we can do anything anyways, right? So there's no difference there. But if I had a function, right? If I had a command that's like get something super slowly, right? It's like we're getting some resources off the network, we're waiting for computers and records to come back, we're paging Active Directory output or whatever. If I do this, I now need to wait for this to execute completely, right? The value expression over here, or the pipeline over here, needs to complete completely before any of this starts executing. And so this is the difference, right? Where had I said get something slowly, right, and I don't use any output buffering, then piping this to for each, the process plugin for each is going to execute as soon as there's one or two pieces of output. And the same applies to the filter. Yeah, absolutely. Okay, where were we? Hashtag was right. Okay. Okay, so we have our array here. We have our array of 200,000 numbers, right? And I want to figure out whether a set of random numbers in that range, or a set of random numbers exists in that array, right? So let me generate some random numbers. We're going to take what do you mean?
Ask A if it includes what you just went through. So you iterate through the A list that we have the 1 to 200,000, and then you just ask the same array.
Oh yeah, you could do that, and we'll get to that in a second. So let's take 100 numbers from this. Again, this is going to be a little bit slow because of the pipeline, but we'll get there. So now we have 100 random numbers within that same range, right? So we know this is going to be true, right? But let's say we didn't know what the numbers were, right? And we want to figure out whether the array A contains our random numbers, or which of our random numbers it contains, right? So what you could do is something like you could loop through all the random numbers, and you could do something like array, or this, where the value of whatever item we're piping from the array equals the value of the random number that we're trying to find, right? And so this is going to be terribly slow. Does anyone care to guess why this is going to be terribly slow? Right. So, right. And so I think, right. And so I think there's a bunch of things here, right? First of all, we now have a nested loop. It might not seem like that, right? But we have the for each loop kind of on the outside, right? And then as soon as we start piping, we're actually creating another loop, right? We're iterating through the entirety of $A, piping that down through the pipeline. So now we have this nested loop construct, right? So this is going to be terribly slow, but let's see if we can execute it before we get kicked out of here. Oh, there's a break after this.
Yeah. There's already staying.
Thank you very much. Again, it's running, it's terribly slow. I would have lost my patience if I'm not trying to demo how slow it is already.
And you've lost anyway.
Yeah. I think my computer might actually be screaming louder just because of this nested loop. Right, so we're not going to wait for that because that's obviously very slow. The kind of first optimization we could do to this, all the comparison operators in PowerShell also double as collection filters. And so that means that instead of comparing one thing to one other thing, what we can do is we can compare a collection to one thing. And what that's going to do is it's going to return every single thing that equals the thing that we're comparing to. So this way we can we have a single value, right? And we want to filter a collection of things. And so we just say this entire array here equals rent. And instead of giving us back true or false, it's going to give us back every single object for which that condition is true, right? And try this. This is still going to be terribly slow because, again,
Why the extra vector array?
huh?
Why?
Just to make it clear that it's a collection, but like this would be the exact same thing.
Okay.
As we can see here, it goes way faster because there's no overhead from all of that pipeline binding to where object. It doesn't need to instantiate that script block. So simply by doing this rather than doing another pipeline, we've actually cut the time down to a couple of seconds, right? So still pretty slow. So what we could do instead is, as I showed before, we took all the numbers and we put them into a hash table, right? So I said before, one of the interesting characteristics of the hash table is that for searching for keys, whether a key contains a value within a hash table, the lookup time is constant. So it's always going to be, first of all, it's going to be very fast, and it's always going to take the same time. It doesn't matter whether it doesn't matter the order in which we inserted it into the hash table. It's always going to tell us very quickly. And so hash table has this contains key function. And so again, we're just going to iterate over the numbers that we're interested in. We have our 100 random numbers. And then 100 times we just ask the hash table, do you have this key? Do you have a key with this value, right? And so what we're going to see here is that it's almost instant, right? In 15 milliseconds, the hash table told us, yes, I have these 100 values, right? We made 100 calls to contains key.
And these 15 milliseconds are the code measure object. Measure command.
Probably, right?
The
Yeah.
table is
Yeah, it is extremely fast, right? So when you're doing things like collecting data from an external system, right? You're querying Active Directory, for example, you're querying a file system, or you're querying an SQL database. If you have like a key value relationship that you want to be able to look up later, like you want to see you want to be able to look up all the users in Active Directory that you just retrieved by their username, for example. Instead of having an array of Active Directory user objects, you want to throw them into a hash table. So you create a hash table, right? So you do something like how many people here work with Active Directory or have worked with Active Directory, right? So we're pretty familiar, right? We're all familiar with the get 80 commandlets, the Active Directory administration module, right? So you do something like this, right? Get 80 user, let's just get all the users because we need all of them for some reason, and properties, whatever that might be. And so what you can do is you pipe this to for each object. For each object also supports begin, process, end. So in the begin block, we're going to create a hash table. It's just an empty hash table. For each 80 user that we pipe to for each object, we're going to create an entry in that hash table with the user's SAM account name. And then the value of that key in the hash table is just going to be the entire 80 user object itself, right? So, and then at the end, we just return that hash table. And so we just take this entire expression, call it table of users. Now, I'm not going to execute this because I don't actually have the Active Directory module on my machine, and I also don't have a domain controller running. But if I press enter now, $table of users is going to be a hash table, right? So later in my script, I have some user object, and it has a SAM account name. And now I need to figure out, oh, what was the manager property of that object, right? Or when was the last time he changed this password? Now, instead of going back and saying, get 80 user, need to retrieve that again with the properties password last set, for example. Now I can just do table of users. And now instantly, I'll have the copy returned that I already retrieved from Active Directory before, right? So this is kind of a nice and neat way of implementing lightning fast caching client side of any data that you're retrieving outside. If you wanna look more into this kind of caching strategy, I have a module on GitHub called PS Cache that implements this pattern using PowerShell classes. So if you're using PowerShell 5 or up, you can create kind of an instant of a cache. It takes one method, the method for actually retrieving the object from Active Directory, for example, and then if you use that instead of calling Active Directory directly, if we already have that in the cache, it's just going to return that object from the hash table, right? And it's going to be way faster, even if you have 100,000 users that you retrieve. Any other questions or things or? Oh yeah, absolutely. Right. So, my claim was that an enum.
I already decompiled it here, and yeah, you were right.
There you go. So we can decompile it as well. So does anyone know what this tool is? This tool is called ILSpy. So yeah, there's also a more advanced version where you can actually edit stuff that's called DNSpy, but let's take this for simplicity. So before this whole type system stuff I was talking about, right? The way that all of this code interoperates is that the compiler doesn't actually compile to machine code, right? It doesn't compile to assembly. It compiles to something called CIL or MSIL in the Microsoft Embedded implementation. MSIL stands for Microsoft Intermediary Language. You have this intermediary language that kind of describes all of these types and their interactions and behaviors. This program can take a DLL, which is just a bunch of MSIL instructions, and decompile it back to C#, or what might have looked like C#, right? But it can also show us like what the IL actually looks like that we compile. So if we take something like just recompile this up here. So we have our C# class here, and we're going to define a public enum, going to extend bytes, and we're going to call it right? So we find this, we build a solution. Oh yeah, I imported in PowerShell, right? There we go. Right. Right. So here I open the DLL, right, the compiled code that we just wrote. Open this in ILSpy, and I have it set to IL mode, so it's going to show me like the actual intermediate language code that's on disk. And so if we look down here, we have this enum type defined, and as you can see here, once this gets compiled, this actually becomes a sealed class that extends the base enum type, and the only thing that it exposes is a set of static fields with the value type that we specified before, right? So here it compiles to an 8-bit integer. So I hope this convinced you.
Yeah, it's interesting. I always was thinking about this as like compile time wrapper over the
Right.
It's interesting because then you can take the enum and you can create an instance of this class that is not defined in this list.
Right.
So I can create something that has type knowledge A and B but has value for it.
Right.
Which I'm not sure how it would represent itself. So then it just probably becomes a number.
I'd expect so.
Then the consumer
I'm pretty sure it would resolve the underlying value, right?
Yeah. Interesting.
Any other questions or any other things I forgot that I promised you?
Maybe like when you were defining in FSharp the class, you are using like the class stuff, and you try doing like the record, like the type that's more native to FSharp.
Right. So.
Yeah, work as well, because then we would have like 3 different type systems.
Right. So I haven't actually checked whether records in FSharp compiles to something that you can import into C#. I'd expect so, but yeah. I haven't looked into what that ends up looking like when you compile it to do that. But maybe we can do something about that at Peace Computer. All right. There's nothing else. Then I want to say thank you very much for being good sports. And again, if you think any of this is interesting or you want to see some of the code I talked about earlier, feel free to hit me up on GitHub or Twitter. I